Number 27 says, 27. 5m minus 3n, and then underneath it, it says 5m plus 3n. Yeah, that's the key thing. I did not teach this. I don't really like this method, but you can absolutely do this, and some people do like it. They want you to multiply. What they're doing is they're setting up a polynomial like you would set up regular multiplication. If you had to do 123 times 17, how do you do that? 7 times 3, so 21. 7 times 2, 14, 15, 16, right? 7, 8, like that, 0. You know, you've done multiplication before like that, right? What they're doing is they're setting up a polynomial like that. So what you do, and you can do this, it's just a way to keep track of it. You start here and you multiply 3n times negative 3n. What's that? Negative 9n squared. And then you do 3n times 5m and you get 15mn. Then you move over across and you take this. What's 5m times negative 3n? Negative 15mn. And then 5m times 5m is 25m squared. You see how I lined up the terms? So I lined up the common like terms. Yeah. What happens with these two when you add them together? They cancel, so you're left with 25m squared minus 9n squared. So that's one way to do this. It's totally fine if you want to do it that way. That's fine with me. It's just another way to do polynomial multiplication. Yes. On a test horizontally. Yeah, I'm sorry. I'm not gonna. I'll just tell you right now. I'm not gonna force you to do this method. Okay. If you want to, it's totally fine. Like if I gave you 5m minus n parentheses times 5n plus 3n, you could do it any way you want. It's neat because the verticality is kind of good. The only time I've really used verticality like that is when I have a really long polynomial, like plus a really long polynomial, and I have to keep track of a bunch of terms. I will stack them up that way when I have a bunch of terms. It's okay this way. I mean, personally, I think it's not the best, but it's totally up to you. Yeah, 42 is really good. It says, explain why the product of the sum and difference of two terms is not a trinomial. Okay, what's the sum of two terms? It is label them for me. What do you want the two terms to be? X and Y. This is the sum of X and Y. And then it says the product of the sum and difference. This is the sum of two terms. We need to multiply by the difference. What's the difference of these two terms? X minus Y. So let's multiply this. What's X times X? X times negative Y. Negative XY. X times Y is positive XY. And what's Y times negative Y? Negative Y squared. What happens when you're simplifying this? Milo, what happens when you simplify this?
The X and Y, XY cancel out.
Yeah, these two terms cancel out, leaving you with X squared minus Y squared. So the question says, describe why the product of the sum and difference of two terms is not a trinomial. What is this? That's a binomial. So is it a trinomial? No, because there are only two terms left. The middle two terms cancel each other out. That's why. Let's see here. 4x cubed times x minus 3 times x plus 2. You can do a lot of different orders here. What do you want to do first, Nikki? Yeah.
I distributed the 4x.
Yeah, so you end up with 4x to the 4th minus 12x cubed. And what is that multiplied by? X plus 2. Yeah, exactly. Turn it into two things multiplied together. Does it matter what order you do the multiplication in? If you have three things multiplied together, could we have multiplied these two together first? Yeah. Sure. I like this. I agree with you that this is what I would do. So then you multiply by x, you get 4x to the 5th plus 8x to the 4th minus 12x to the 4th minus 24x cubed. Anything combined in there? Yeah. How many x to the 4ths do you end up with? Negative 4 of them. And then anything else cancel? No. So here you go. There it is. Is that good? Cool. Ma, what's the question?
I didn't have a question on it.
2m times 5m is what?
No. Can you go to the way I did it?
No, I have no idea what way you're talking about. I need more. Does that 5m get multiplied by the 2m? In this phrase, Mar, technically speaking. No, it doesn't. So you see those parentheses I added in? Right here and right there? You must put those parentheses in if you're going to do that.
But don't I end up doing that in the next
You do, but that work is incorrect. You would not get full credit on your work. This right here is the equivalent of like leaving out a period or a comma in a regular sentence and turning it into something that means something else. What I'm saying is 2m plus 6 times 5m. If you just wrote that, that does not equal 2m times 5m times plus 6 times 5. Do you understand what I mean? It's not the same thing. So if you put those parentheses, sure. But this is exactly what I mean. As long as you do everything times everything, that's fine. I would prefer, honestly, I would prefer if you did this one right here. Sorry. When doing this one right here, I would prefer that you do this one times both first.
Yeah, and that's what
I would prefer that, yes.
But the book said
I don't care. The book is not infallible. The book is not infallible and it's not perfect. It is another way they present it. The reason I recommend this, it's kind of like why do we use x and y so much as variables?
it's easy.
No, not really. Why? Well, why is it easy? Why do we use x and y as our variables? Because they always use it. The point is, how many different orders can you multiply something? As many as you want, really, right? If it's a times b times c, it can be a times b times c, or c times b times a, or a times c times b, or c times a. There's 6 ways, right? The point is, if you're all going to do similar work, I'm not saying you need to work exactly the same all the time, but when I'm looking at some multiplied out polynomial, it would be kind of helpful if, in general, you followed the same order. I'm not saying you have to do everything exactly the same way. The point is, it would be nice, because when I look at this, I say this term right here corresponds to the first 2. This one corresponds to that multiplication. The fourth one corresponds to that, and that corresponds to that. It's much easier for me to follow. It is much easier for me to follow. Similarly, the book presented us with this, like 3m minus 5n, 6m minus 9. Can you multiply it out that way if you wanted to? Sure. It's just weird. So do you need to know so many? No, you don't. If you really like it for some reason, that's totally fine. Some people like columned math. There's a whole field, matrices. You have to do tons of column math. It's fine. Any last question? It says find each product. So for this one, what does that mean?
Well, when it says go back to example 6 is like,
Okay, so you're saying go back to example 6. Okay, so it says, yeah, it gives you examples of how to do them.
yeah.
Okay, so what does that mean? It's x plus 1 times what, Milo? What does squaring mean, Milo?
Means to square.
So tell me again, it's x plus 1 times?
Times 1.
No, it is not times 1, it's times what? Okay, answer this question. What does squaring mean?
Means to multiply by
Itself, so it's x plus 1 times? Yes. So now you just FOIL it out, you get x squared.
Yeah, but the way that they had us do it in the book is really weird.
I'm looking at example 6 right now, and they do
m squared plus 2.
yeah, there's a formula here. What they do here, and again, does this make sense and does it work?
Yeah,
So stop. We have covered 296 pages of this book so far. Did we do every last piece of maneuverability that they gave you in this book? Absolutely not. If you have a method that works, stick with it. What they're telling you, I will explain what they're giving you. They're giving you this, Milo. They're saying, let's say you had x plus y times x plus y. What's x? Oh, you get x squared plus xy plus, what's the last term?
Y squared.
Y squared. So what do you get? X squared plus 2xy plus y squared. So this is a formula for multiplying out squaring a binomial. So if you know x and you know y, you can just plug it in right there. Is that a formula you need to memorize? No, because can you just multiply 2 binomials out? Just multiply them. Just do it. You don't need to memorize a formula for this. Just do it. Yeah, well, that's right.